One day, Chappie the dog is standing on the floor when she saw her food on the other side of the room. She walks from her current spot towards the food on a straight line. This is an everyday situation that we take for granted. But for a physicist, this can be an example of one-dimensional kinematics, or motion in one dimension. Welcome, calculuses. One-dimensional kinematics is a movement in one dimension. In our case, Chappie moves in the x-axis towards east. Her first position can be labeled as x sub 1, while her second position can be labeled as x sub 2. X sub 1 is where she was standing before she moved, and x sub 2 is where the food is. As she walks towards her food, there is a change in her position x. To shorten the statement, instead of saying the change in Chappie's position x, we can symbolize the word change as delta. Therefore, we say delta x, which means change in the x-axis. And from the previous videos, we discussed that position x is a function of time. And this event, Chappie walking towards the food, is happening for a time interval, or over time. Also, we can say that there is a change in time. We can write it as delta t. Therefore, the change in position x is happening over time, which we can write as delta x over delta t, or the change in position x over the change in time t. Delta x over delta t, or the change in time over the change in t, also means position 2 minus position 1 over time 2 minus time 1. This can be written as x sub 2 minus x sub 1 over t sub 2 minus t sub 1. We have already discussed this in our previous videos, and this is called average velocity. While the infinitesimal change in distance with respect to time is the derivative of position with respect to time, which is called instantaneous velocity. If Chappie then runs faster and there is an infinitesimal change in velocity with respect to time, then the derivative of velocity with respect to time is acceleration. These are derivatives. See lesson number 2 lecture video for more details on derivatives. Motion in one dimension can also happen in the y-axis, or the north and the south directions. An apple falling from point A to point B is an example of this motion. As it falls, it accelerates at 9.8 meters per second squared, the acceleration due to gravity here on Earth. So the next time you look at the world around you, observe the motions of objects. Are they moving in one dimension? If so, is it on the x-axis or the y-axis? Kinematics in one dimension will make you realize that even a simple motion requires a lot of physics. Thanks for watching. Hope you pass your calculus class.